Okay, so what we have seen so far is the central tendency, the variation of the data, correlation in the data, and we have seen the skewedness of the data and the kurtosis existing in the data. So now we are slightly moving towards the frequency tables and what are the different frequency related statistic that exists in the data. As I said earlier, that the frequency is a very key statistic to the nominal form of data like gender, high, medium, low. So let's see how what is cumulative frequency quickly. It's a very simple table which has been drawn here. So we have total 6 age numbers 1 to 6, and frequency is the number of people falling into these age groups, falling into these ages. So there are 5 people with 1 year kids, there are 3 kids with 2 years, 7 kids with 3 years, and so on. So what's a cumulative frequency is when you need to add both the frequency and represent it here. So when I say cumulative frequency at 2, that means that all the kids which are less than 2 years. So less than 2 years are 5 and 3, 8 both. And similarly, once we move to the next one, we need to add 3-year kids as well. So that means 8 plus 5 is 15. So that's the cumulative frequency concept. We can group the ages. We will see, because a lot of places we have multiple categories and we would like to group some of the data based on some logic. So in the example, when we go to the workshop mode of R, I'll explain you. There's a function called break. So we can break the data, bring them under some clusters, like they have brought the age group under some clusters into 3. So they have reduced 6 to 3 and plotted the frequency again. Data presentation. So there are two type of statistical presentation of the data. Either it can be graphical and numerical. So graphical presentation, we look for the overall pattern and for striking deviation from that pattern. Overall pattern usually described by the shape, center and spread of the data graphically, and the individual value that falls outside the overall pattern is called outlier. So bar diagram and the pie charts are used for categorical variables, while histogram, stem and leaf and box plot are more used for the numeric type of data. So let's quickly see a bar diagram. That's the representation of the categorical variable. So what bar diagram does is it lists the categories and presents the percent of the count of individuals who fall in each category. So there are 3 categories here, and the frequency is 15, 20, 60. Proportion is called relative frequency also. That gives you a proportion of that particular group count divided by overall count. So in this one, the proportions are 25, 41 and 33. That's the bar chart. Second one is a pie chart, as a similar representation, but it's an alternative form of representation. So whenever we have one pie and we would like to show the bifurcation, then pie chart is more suggestible than the histogram. So treatment group, and there are different frequencies. Similarly, it has been shown for the pie chart. So pie chart lists the categories and presents the percent or the count of individual who falls into each category in a different manner. Histogram, see, histogram, though it looks similar to the bar chart, but bar chart is more from the categorical variable perspective, but histogram is more from the numerical variable standpoint. So histogram overall pattern can be described by its shape, center and spread. The following age distribution is right skewed. The center lies between 80 to 100 and there are no outliers. So this is a histogram, and there are few statistic being mentioned here, and we will also calculate the statistic when we go to the data. A quick overview on mean, standard error, median, mode. So mean is more than median and mode. So if mean is greater than, that means the data is the right skewed data. What's the maximum value, minimum, skewedness, kurtosis? Kurtosis is negative. That means it's mostly a flattered sort of, there are no peaks. Okay, so getting more into numerical representation of the data. A fundamental concept in the summary statistic is that the central value of the set of observation, to the extent which is central value, characterizes the whole set of data, and it measures the central value such as mean, median, which would be coupled with the measure of data dispersion, that is variations that we have read in last few slides. To understand how well the central value characterizes, we have seen this similar example also. We have taken 2 data sets, but the mean was same, but the actual data was being explained by the variance and they were not the same data set. Okay, what is a box plot? Box plot is a visual tool that illustrates the distribution of a univariate dataset. It illustrates the median, upper and lower quantiles. So remember, the median is the middle quantile where 50%. Upper quantile is where the 75% of the observation are below, and lower quantile is where the 25% observations are below. Upper and lower deciles and any outliers if available in the data. Let's see a quick snapshot of the box plot. The middle part, which we call as box, there would be a one line that will tell you it's a 50 percentile, and this is typically falling into 0.21 to 0.26. Here it can be 0.25. In this data, it can be 75 percentile is this, which should be 0.27 or 0.28, and this is the bottom one, the 25 percentile, and this is the 10 percentile, and this is the 90 percentile. This is how typically a box plot will show you. We'll see in the experiment or in the classroom or the workshop mode how the box plot is being plotted. Similar here, they have plotted max and min instead of deciles. This is the median, this is the quartile, the upper one, this is the bottom one. This is the similar histogram that we have seen. Okay, so this is the frequency distribution again. So we will soon, so to summarize the data, there would be different functions, and when in the workshop we'll see what are the different functions: mean, median, mode, box plot, scatter plot. Okay, so it's very important that which summary you would like to choose, whether you want to go for quartiles, whether you want to go for ranges, whether you want to go for mean, median, mode. It's really critical, and it's really important, and that's, you can only take that decision once you have a visualization of the data, once you have all the metric in hand for the data. So typically with this example, if I have everything at the hand, then probably I would say that mean, median, mode doesn't suffice, because there's a difference between mean and median, and there is a very high variance as it is. So I need to choose my statistic properly based on the business requirement. Okay, these are again the commands that we'll use: summary, mean, variance, standard deviation, minimum, maximum, histogram, box plot. Yeah, so again some example. So this is how this histogram of body weight and brain volume, and these are 5 kids, and this is the body weight in a pound, in some milligram, and this is the brain volume. And so with the functions we have plotted the regression line, we have plotted histogram for individually for both of them. Okay, so the next important section is, so this was the basic statistics theory, and we soon jump to the real life implication in the formulas, and how do I calculate these statistics in R. And before we move to that one, this is very important thing, like control flow, because when we are programming in the R, when we will go into the industrialized mode, we do it for more number of data and more number of loops, then you need to have a control flow. So how the control flow works in the R is multiple type of looping, but there are two primary controls. One is for control, one is while control. So this is the syntax for for. So if you want to do anything multiple number of times, you have to write it like this: from start from 1 to 10 and print. So this is a sample program where it will print for x number of times, or 10 in this case. So similarly with the while loop, if I want to print the square root of I, then this program will help me in printing the square root. So this is the syntax. So whenever you want to go in the loop or an industrialized mode, when you want to execute for multiple observation, then for loop and while loop comes in very handy, and they have their own control mechanism to terminate. So the control mechanism is predefined that it will work 10 times. The control mechanism defined here by a number, saying that whenever this number is less than 10, then till then you can go on and do it, run this flow. Similarly, function also is a industrialize is a key thing which is available in the R, which helps us in industrializing. So let's say whenever I want to perform a critical operation to multiple observations or multiple metric, then I don't have to write that function again and again. Rather, I write a function once and I use that function. I use that function for function in a repetitive manner. So it function helps us in helps in the helps us in the getting the industrialization done from the R perspective. So we have created a summary statistics proc. So while going through all the different statistics, we have created a procedure also. So whenever next time when you want to do a summary statistics for a metric, then you don't have to write formula again and again that give me kurtosis, give me quartile deciles. You have created a procedure, you can just use that procedure, feed in your metric, and you will get everything in a tabular form. So this will do as a case study today. And so this is just a screenshot again, more of a teaser. Then there are different distributions exist in the data. We might pick up some of the distributions, and that will help us in understanding what was the significance, what is the hypothesis. The hypothesis is a very important term in statistics. We should know what is hypothesis. So this is a teaser for all those functions that we'll use in the next function. So next we will quickly move to the R workshop mode, where we will explore different functions of statistics. We will see an example for the control flow, and we will learn how to write an R function, and with a case study of writing a summary statistic function.